Everybody for your patience. Some brief words of introduction. Hello, good afternoon. My name is Alanka Oswald. I'm the Chief Operating Officer at American Friends of the Alexander von Humboldt Foundation in Washington, D.C. And I'm really pleased to welcome you to our first hybrid Humboldt Digital Dialogue session. So we have alumni and colleagues joining us from all over the country via Zoom this afternoon. And we also have our speakers and some special guests joining us from the campus of Northeastern University in Boston. I want to take this opportunity to thank you for joining us this afternoon, and special thanks to our board member and DEI committee chair, Dr. Andrea Stitz, for coming up with the concept for this event, and to my colleague, Jessica Hamilton, for all the work behind the scenes to make the event a success. We're also grateful to our two distinguished speakers, Dr. Saif Savage and Dr. David Bao, for sharing their expertise today, and to our board member, Dr. Dale Medeiros, for moderating what promises to be a fantastic session on some really important issues. Dale, the floor is yours.
Thank you so much, Alanka. Thank you, Andrea, for coming up with this great idea, and Jessica for your support. Welcome to this discussion on Can AI Help Create a More Sustainable World? I'm Dale Medeiros. I'm a member of the board of the American Friends of the Alexander von Humboldt Foundation. I'm a myself. And I feel lucky to be able to co-host this and be part of this discussion. The purpose is to share insights into some of the latest technological advancements and to explore a few of their potential impacts about the world of artificial intelligence. And the dialogue is really timely as investment in AI and related technologies expands rapidly and diversifies the increasing computing power of the present that enables researchers to turn digital reams of data into information and insights. Conversations among scholars, professionals, governments, and the global citizenry, it's driving this need for more understanding about how these phenomena all interact. And moreover, as these technologies increasingly touch so many more aspects of our daily lives, the drive to have greater understanding emerges about how artificial intelligence impacts people, professions, the environment, or how access to these technologies can be made easy, equitable, and positive. So we're really, really fortunate to have two leaders in the field of AI research, both from Northeastern University. Our first speaker is Professor David Bao. Dr. Bao is an assistant professor of computer science at Northeastern University's Khoury College of Computer Sciences. His lab studies the structure and interpretation of deep networks. The goal of his work is to provide greater understanding of the rich internal structure of deep networks. He regards this as a grand and fundamental research question with many practical implications. Through this work, he aims to lay the groundwork for human AI collaborative software engineering, where humans and machine-learned models both teach and learn from each other. He's the holder of more than a dozen patents. He not just teaches, he does stuff. Our second speaker is Dr. Saif Savage. Dr. Savage is an assistant professor at Northeastern University in the Khoury College of Computer Sciences, where she directs the Northeastern Civic AI Lab. Dr. Savage's lab designs, builds, and studies public AI tech to empower gig workers, federal governments, industry actors, and NGOs to collaborate to achieve their collective goals. Dr. Savage has been recognized by organizations such as MIT Tech Review, UNESCO, the Federation of American Scientists, and she is a fellow at the Center for Democracy and Technology. So some housekeeping, there'll be presentations from Dr. Bao, Dr. Savage. We'll have a question and answer session because we want this to be as participative and involved as we can make it. We want you to have a voice in the conversation. And then we'll wrap things up, get everyone home just after 5. So Dr. Bao, the floor is yours.
Oh, that's great. So I'm really honored to be here and have a chance to meet you all and chat with you. Is somebody projecting my slides? Am I going to be able to see them?
Yes, I'm opening them now.
Okay, that's great. So so my area is in machine learning, interpretable machine learning, and it's been a really tremendously exciting time in the field because there's been, as we all know, a tremendous number of advances in the last few years. So we all know, go to the next slide, is that machine learning, data and ML is powerful, but underlying all these new capabilities that we are witnessing in AI there are some serious underlying issues, which I'm going to talk about today. So to explain it, I want you to just think about the process that you use to create an AI. So go ahead and advance a few clicks through this slide. The process for making an AI is you start with some data, and then to create an AI program, instead of having a programmer do the traditional programmer thing and figure out the logic of the program, instead use a machine learning algorithm, expose it to the data, and then one more click. The outcome of the machine learning process after potentially days or weeks of training is a trained model. So the thing that makes deep learning or machine learning different from traditional programming is that the trained model is basically an automatically created program. The programmer doesn't really have a sense for how it works. It contains a bunch of optimized parameters that the machine learning program extracted from the data. So now that may sound complicated, but in the end, a program is a very simple thing. So if you click a couple times, you'll see that a learned program, a neural network, is just a function. It takes some input, like some random numbers. It does some arithmetic on those numbers, and then it produces some output. So in the press recently, there's been a lot of attention on these amazing AI models that can create realistic photo images. And this is an example of one. This happens to be a StyleGAN that creates images of rooms. If you give it a different input, which if you click on it, you can see, you'll get a different room output. So click a couple more times and we'll go to the next slide. The thing that makes this model a little difficult to understand for people is that it's actually quite large. It has 30 million learned parameters. And so even though it can create these realistic images, it leaves us with this question, what is it actually doing inside? So what I do in my work is I basically am in the business of cracking open these models to ask the question. So go ahead and click once. So, what do components of the neural network do? Like we can go to individual neurons of the neural network and say, what is this neuron control? So let me just demonstrate what you can do here. You can test these things by forcing neurons on and off and quantifying what kind of results you have. And you find that the neural networks learn interesting things about the world without having been explicitly trained on them. For example, this neuron here I'm showing you in StyleGAN is actually a neuron that controls the level of lighting in a room. So if you literally turn this single neuron on and off, it will turn the lights on and off. And so the remarkable thing about it is that the sort of no programmer intended to create this or actually understands like how the lighting solutions are found by the neural network. But if you mine the neural network for its internal concepts, you can find these interesting things. And so why is this interesting? Well, as these networks grow bigger, 30 million parameters is a pretty complicated model. But if you click ahead, you can see where the trend is going. So this is like a scale model of what a couple years after StyleGAN came out, people are starting to build these larger models, like the representative model is GPT-3, which has 180 billion parameters, billion with a B. It's more than 1,000 times larger than the neural networks we were working with just a few years ago. And so the amount of complexity that's contained in these things is kind of mind-boggling. And so so one of the big priorities I think that we should face as a community is to figure out how to crack open these models and understand them. Another concern is that these models represent quite an expense when you create them. So if you click ahead, you can see how much energy it took to create GPT-3, like 1,200 megawatts of electricity. That's enough power to power 120 North American homes for an entire year. So these models are things that are pretty expensive to tinker with. You can't just like create another one to run an experiment, and it demands a new science for how you crack these things open and understand them and control them, because we're not going to make another 100 copies of this thing. So go ahead to the next slide. So I'll just close with a little example of things that you might want to do by cracking open deep networks. So GPT, as complex as it is actually another conceptually simple model. Again, it's just a function, but it's a function that works with language. So in this case, if you click a couple times, you'll see that it takes a piece of language and it predicts what the next word will be. It's saying that the Space Needle is in downtown, should be followed by the word Seattle. So it is actually, this GPT model knows a lot of things about the real world. And what you can ask is you can say, well, where is that knowledge? Can we locate it? Can we find it and fix it when it's wrong? And it turns out that even in these models that are 1,000 times bigger, we can locate specific knowledge. So the next slide just sort of shows some of our experimental results and how we trace through the internals of these models and localize where knowledge would be. Go ahead and click a couple times. We'll go to the next slide. So these are neurons that actually store the knowledge of the Space Needles in Seattle. And once you find these kinds of things, you can actually edit the model. If the Space Needle needs to be rewritten to be in a different location, like in Rome, you can reach into the memory of the model and change it. And then the interesting thing is when you do that, you'll get all these things which we call entailments. The model will reason about what the effect is of changing the Space Needle to Rome. Now, instead of being on the Puget Sound, it's next to the Tiber River. If you want to brush up on some tourist knowledge, you might want to learn a little bit of Latin and be prepared to enjoy some great views of Rome. And instead of going and ordering the famous American space burger when you visit the Space Needle, if you click ahead, you'll see that it'll suggest that you go and get the delicious pasta with the local sauce, right? So you can see that these models actually contain really, really interesting relationships, and if you can understand how they reason about the world, you can expose these relationships and model counterfactuals. You can also model things that need to be corrected in the world. We're not going to train another GPT-3. It's too expensive to do that. But we can go in and we can fix things as the world changes. Like just a couple of days ago in the United States, we had an election. Many seats changed hands. The GPT models are all unaware of this. But my students have created a model. It just took them a couple hours to create a model that has all the new election results in it. So that's just an example of the applications. Okay, so go on to the next slide. I just want to wrap up by pointing out what we have here is a new computer science. Like the whole field is being redefined in these few years. Click ahead through these animations slowly. So traditionally you would write a computer program by hand. A programmer would do this, and we've been enjoying the fruits of this new method where instead of creating programs by hand, you use machine learning to create networks trained from data. And what I'm advocating and proposing is that this picture here is incomplete. And what we really need to be pushing towards is a more complete picture where after you get a model, the real goal is for humans to gain and share insight about the structure of the world that has been learned by the network. If we crack open the network, we can find out what the network has actually learned about in the world. And I think that our real goal shouldn't just be to get networks that can do cool new tricks, but networks that teach us about the structure of our own world. So that's my summary of my research for today.
So should I go next?
Maybe.
Or maybe I don't know. We could open it up also for questions. Or
What's the right structure? Maybe what?
You will go ahead.
Why don't you go ahead and go next? Yes.
Okay. Thank you very much, everyone. And thank you especially to Andrea for the invitation to present. I'm very excited to be here. Es freut mich sehr, euch kennenzulernen. Ich habe Deutsch an meiner Universität gelernt und ich bin sehr froh. I studied German in undergraduate, and so it's such an honor to be able to finally use that knowledge. And I'm very excited to be here and build connections. So I'm Dr. Savage. My research lab, if you go to the next slide, my research lab has been focused on thinking about, well, how might we design sustainable AI, especially within the context of work. And today I will be presenting to you about how do we start to solve and think about this question. Next slide, please. So when we start to think about this, this context, it's very important for us to consider that on one hand, AI has been creating millions of new jobs. Next slide. Now, a lot of these new jobs focus on having human workers complete the tasks that are difficult for the machines to do. So we might have, for instance, human workers who are going to be labeling images. And through the labeling of these images, the machine learning models will now be able to better understand the world around them. For instance, this is a sign, this is not a sign. Likewise, the workers might be, for instance, transcribing audio. Through this, Alexa might be able to better understand what the end user is saying. They might also help in content moderation. Through this, Facebook, for instance, might not show you photographs filled with hate speech. Next slide, please. Now, these types of jobs that are being generated have been on the rise. And it is expected that by 2027, 60% of the US workforce will be involved in jobs where you have human workers working alongside the AI and helping the AI to better complete the tasks that the AI needs. And so this goes back to what Professor David was saying around integrating humans who can now use the outputs of the AI to get insights. And so it looks like it's a very exciting field to be in, where you have humans and the AI working alongside. Next slide, please. Now, these types of human AI interactions have created a number of futuristic realities. Some of them are, for instance, voice assistants who can simply respond to a number of different questions that we have. We also have self-driving cars who can understand the world around us and drive us from one place to another. Next slide, please. And as a result of these new futuristic realities that these human AI interactions are creating, a lot of research has gone into thinking about how do we optimize integrating human workers into our AI pipelines? How do we improve the labor outcomes of these human workers so that we can get quality AI results? Next slide, please. And so as a result, given that we're on one hand generating all of these futuristic realities and we're creating a lot of new jobs, we could say, yes, the AI workforce is good. We're creating this amazing future. This AI workforce is good, but the reality is also that it has created a new global underclass. Next slide, please. So my research has uncovered that on one hand, the human workers who are operating behind the scenes in our AI industry are earning less than minimum wage, and they're also stuck with opportunities where they have limited opportunities to grow and develop themselves. Next slide, please. As a result, I'm very interested in thinking about, well, then how do we design sustainable AI, especially within this context of work? Next slide, please. And so today I will be presenting some of the research that my lab, who's also here, has been doing around thinking about how we can design a sustainable AI workforce. Next slide. So I argue that in order to design a sustainable AI workforce, we need to, on one hand, understand what are the values that the different stakeholders who are involved have. And then we can also connect with different social justice frameworks in order to map out what are the main problems that these stakeholders have. And through this, we can start to design AI for good, an AI that is much more sustainable. And so in order to understand the values, I connect with HCI, human-centered design. And so we do a lot of interviews to understand people's needs, to understand their values. We then design technology. And through the design of technology and how people are now engaging with the technology, we have now a better understanding of people. And it's a whole cycle where we are improving our technology through the understanding about how people are using the technology, and we're focused on designing technology that can address some of the main challenges, social justice challenges that people are facing. Next slide, please. So on one hand, my research has been focused on helping displaced rural workers be able to develop their digital skills to access new types of jobs. So we recently won a large NSF grant that focused on connecting with the public libraries. And then in the public libraries, we give workers who, for instance, they used to depend on coal mining, but now coal mining is not a sustainable form of energy. And so as a result, they're out of a job. And so we're helping them to develop new digital skills and access online jobs. Access jobs online where this allows them to not have to abandon the rural towns. It allows them to stay within the rural towns and earn a good living. An interesting thing to consider is that that's the state of West Virginia where we have been deploying a lot of our tools. An interesting thing to consider is that even in places where they were largely marginalized, the workers in those regions were still able to access public libraries. And so the blue dots are public libraries, and the state is color coded per county, depending on the economic stress levels that the county has. And what we notice is that in the United States, even in places that are that have highly stressed economic levels, they are still able to access public libraries. And so that's a way in which we're able to create these types of sustainable workplaces for rural adults to be able to come in and start to develop their digital skills. And UNESCO recently recognized our work as one of the most impactful AI research in the world. Next slide, please. This is a little bit about how our tools look like. So this is a digital labor platform from Amazon. Workers here complete tasks, and then they earn a payment. Next slide, please. What we have been doing is we're developing web plugins through which, on top of the digital labor platform, workers can access our tools and they receive guidance on how to complete labor so that they can develop their skills and access better jobs online. And so this the green interfaces are our web plugins, which allow workers to receive coaching, coach other workers, and through this start to help each other. Next slide, please. We have also been working with rural communities in Latin America. And here we have been helping them to design efficient stoves. So this is also looking at how we can design more sustainable technology. So in order to design this technology, we conducted a series of interviews, and we lived with the communities for actually several years to really understand their needs. So some of the things that we discovered is that the rural communities were composed primarily of women, because the men abandoned the towns to go into the city to find work. As a result, we decided to create technology that the women themselves could manipulate in case the technology broke. And so we made this technology to function with clay. The clay is something that it's easy for the women to be able to modify it without having to be very strong or even to have deep technical skills. Another aspect was that we identified that a lot of the technology was not used when it was brought into these rural towns because it was designed for Europeans. It was not designed for following the traditions of Latin American communities. Here, this one is in Mexico. And so what we did was that we designed the technology to also follow the traditions of the community. And through this, the community started using the technology that they were building together much more. Also, we created it so that it was a very collaborative process where all the community came together to build the technology, and that also made the technology much more sustainable. And so some key factors around designing sustainable technology was understanding the traditions of the communities and also understanding what were their needs and values. Next slide, please. And so again, I argue that in order to design these types of sustainable technology, sustainable AI, it's all about understanding the values that the different stakeholders have, connecting with social justice theories, and through this we can design better technologies for the different workforce and for different regions in the world. Next slide, please. And so thank you very much. It was a true honor to be here. Here's my contact information, and thank you. Danke.
Great. That takes us to the question and answer. Maybe it's easiest, Alanka, if we just allowed people to open up the mic and ask questions directly. Or park them into the chat if you're not in Boston.
Sure. Just raise your hand and we'll call on you if you have a question or comment.
I have one for Dr. Savage. I'd like to sort of, I was wondering if you could just share some more insight about the applications of your research to the rural poor. Speaking in an American context, I drove through central Pennsylvania and New York yesterday, and as you were talking, the experience of the drive and that which I saw really connected. And I saw, you know, lots and lots of examples of urban poverty that made me think, what are some specific examples of in your work and its applications to the folks in central Pennsylvania? Because it wasn't really clear about the types of skills that they might develop and then apply.
Yeah, so that's a great question. So it's on one hand developing skills to get on digital labor markets where they can work alongside the AI. So some of the issues is we first had many courses with the people in West Virginia to understand what were their digital skills. A big issue was that they had very heterogeneous digital skills. So for instance, for some of them, it was even hard to do copy paste or just get on a word editor. And so our tools focus on guiding them on how they can create accounts on digital labor platforms. How do they find work on digital labor platforms? How do they market themselves on digital labor platforms so that employers can hire them? How do they set up even their banking account so that they can get paid for work? And so a lot of our tools have focused on helping them to develop onboarding skills for getting on the digital labor markets. And I would argue that the advantage of a rural workforce that works online is that this way they do not have to abandon their hometowns. It's also taking advantage of the fact that for several of them, it becomes also expensive to have to travel, for instance, to their different workplaces. A number of the workers that we interviewed expressed that they used to work, for instance, at Walmart, but the issue with Walmart was that they had to travel to get to that workplace. And these types of online jobs allowed them to not have to spend any gas and have a lot of flexibility also with their families, considering also that there's a number of women who are involved in that workforce.
That's fantastic, yeah.
Thank you.
Yeah, thank you. I think I see Reinhold Mann.
Yeah, Reinhold Mann, University of Tennessee in Chattanooga, Tennessee. I have a question for Dr. Bao. Can you say a little bit more how you zero in on these nodes that are responsible for certain features in the imagery? It's basically a nonlinear system identification problem, I suppose, but that doesn't really lead you to the solution, you know, that in and of itself. Can you say a little bit more about that?
Yeah, absolutely. It's been one of the focuses of our whole field in machine learning for some time. The area is generally called attribution analysis or sensitivity analysis, and the basic question is, how much do particular components of a complicated model contribute to the model's final output, final decision. And the thing that we found is that sometimes the simplest methods work the best. And so I'd say I put the methods in two categories, and one is to look for correlations between the kinds of outputs you're looking for and the signals that you're investigating. And then the other type of experiment is to look for causal effects, to actually intervene in these models, change what some of their internal computations are, so for example, force a neuron on or force a neuron off, and then observe what the effects are. And And what we found is that as these models get larger and larger, the correlations become a little less dependable as a way of understanding what's going on. The models are just too complicated to trust the correlations, but the causal effects continue to be a really good guide. And so that's basically what our lab is developing. We're developing a whole number of very clever causal interventions that you can do on large, complex AI models to make it easier for people to understand what the structure of the computation is. Basically, you go in, you change parts of the model in a number of different ways, and then you observe what the effects of the changes are.
It's kind of like a deletion test in biology, right?
Yes, exactly. The biologists are dealing with complex systems too, and these causal experiments, we get a lot of inspiration from biologists who've been at this art for a long time.
Yeah, very good. Thank you very much.
Sure.
Are there any questions from the Boston audience?
Well, I mean, I think we had a conversation the other night, just trying to understand like the limits of this model, David, that you pulled,
Yes.
put together. Like, so it's great. I mean, it's kind of cool how you can turn lights on and off, and not having to retrain models and use a lot of energy. But in real world situations, what are some of the limits that you're coming up against?
So I think that the stage so as amazing as these AIs are, we're still in early days of doing things. So I think that in the ideal case, you'd be able to go into a model and customize it and have it do anything that you wanted by inserting some new knowledge, by changing some of the rules and seeing what the impacts are. But I think that one of the things that we're finding is that our AI models today are really good at some things, but then hidden behind all these sort of surface things that they're apparently very good at, they also make, sort of very poor underlying decision-making algorithms for other types of things. And so I feel like one of the things that you can get from cracking open models and looking at the inside is to figure out when a model is actually being very smart and when a model is just using some, almost like some trick to fool people into thinking that it's doing a good thing. And so it can be hard to figure out the difference between those two things looking at the outside, but a lot of this starts becoming more apparent when you look at the inside of the model. So for example, a model will sometimes predict a fact out in the world, and it'll sometimes predict it correctly, and you'll be like, wow, that's amazing. It knows, it knows this person who was born in Tokyo. But if you go and look at how the model predicted on the inside, sometimes you'll see that the model really was smart, that it is looking at the entire person's name and recognizing that the person is from Tokyo. But then other times, you can see that the model is not looking at the whole person's name. Maybe it's only looking at a few syllables in their first name and didn't even bother to look at the last name. And it's just making this guess. It's actually a little bit of, internal bias in the model saying, well, this person has this Japanese sounding first name, it must be Tokyo. And now in a lot of cases, that's correct. The model would get a good score for making that guess, but just on the outside, it's hard to tell the difference between when the model actually knows something and when it's just applying some bias. And so, so these kind of things are the kind of things that we're able to get insight in today, sort of at this nascent level of our imperfect AIs.
I also had a question for Dr. Savage.
Oh,
So in terms of like the next steps, or how do you see this expand, like this work expanding in the future, or like what do you think would be the next steps after?
I think some of the key next steps is, on one hand, realizing that when we're designing technology for rural areas, we do need to take a different approach. And so part of my research has focused on starting to define a new agenda for how do we make sustainable AI, for instance, for rural areas. Because it's not the same to work in rural areas as to when you're working in cities. Simply, for instance, for participants, it was very costly for them even to take part in our research. And so you have to consider that you need to, for instance, give back to the community in a faster way than you would do normally in cities. Also, you have less participants always in your user studies, and also participants who can be very diverse, which makes it hard, for instance, to create these generalizations about how a population is working. And so on one hand, I would argue it's defining an agenda around how to create sustainable AI for rural regions. And I'm very interested in designing technology where we can especially empower with rural regions the new workforce of the future, instead of abandoning them and forgetting about them. Thank you.
So it's the use of AI to identify alternate jobs for underserved communities, right? It's not generating AI jobs for them.
Exactly. It's using the AI to help them, for instance, access new types of jobs, help them develop their skills, and developing technology that is tailored for them. So it might also, the AI that we develop for rural regions might be different in the design than the ones that we're developing for cities.
Okay, thank you.
Thank
And we
you.
have a question from Elizabeth Trujillo. Would you like to ask your question?
Sure. Hi, can you hear me?
Yes.
Yes. Hi. Thank you both for that fascinating presentation. I was a Humboldt fellow in the Max Planck Institute in Heidelberg several years ago, and I benefited very much from my work there. And my work is mostly in law, international economic law, and sustainable development in the environmental area. So I had a question for Dr. Bao in terms of what can AI help us? How can AI help us with respect to understanding our natural world and maybe coming up with climate change strategies? And then for Dr. Savage, some of my work is also in Latin America. So I was wondering, your work is fascinating in terms of trying to use AI for rural communities, and this is very connected to development and law and development. But I'm sure you've come across infrastructure issues in those areas. So I thought maybe you could speak to those a little bit. What kinds of infrastructure problems did you find? Were there ways of overcoming those? How did you overcome those? What are things that could be done in the future to help overcome those?
Yeah, really great questions. I don't know if you want to go first.
I can answer briefly first. I think that you can think of AI as just the next stage of computation. We have a lot of computational tools which can be used to address environmental problems, whether it is in climate modeling or in creating new green sources of energy. Material science is being driven, like the entire field of chemistry has been redefined by AI recently as sort of our new computational models are making it possible to design new materials and chemicals computationally before we bring them to the lab. It's sort of emerging technologies can be accelerated, maybe hopefully to get us out of this terrible bind we're in with really accelerating climate change. Computation is just another tool in the chest, and I think that it's fortunate that we live in this era where we have accelerating computational technologies that may help us with these things. I think that there's some real opportunities there. I think that there are also some challenges to be aware of. I highlighted how AI is a potential polluter when we're creating these huge models. And I think another thing for us in the AI community to be aware of is the environmental footprint of the work that we do, and to make sure that we continue to invest in doing AI efficiently and in a clean and green way. we can consume a lot of electricity in doing these computations. So it's not something that can be done frivolously.
Thank you.
And I'll go now with the question around how is the infrastructure in Latin America different, for instance, than in the United States, which I think is a great question. I would argue that on one hand, the United States, what we found was that almost all counties did count with a public library. So even though they might be highly economically stressed, they still had a public library with computers and with internet. In Latin America, I work particularly in Mexico. I'm originally from Mexico, and so I have that connection. They're usually rural areas might have the schools are especially the ones who have the computers, and so you might not have as strong public libraries as the United States. But you can have, for instance, schools that what they will have more than computers is usually satellite TV. And so it's understanding that the infrastructure, it will be different. Internet many times in rural areas in Latin America is not always present. But what you can have many times is really good satellite TV that can, and so you have to think about maybe the course material that you're generating for that workforce will not come through computational tools, but maybe through, for instance, these types of videos that you might be creating for them. Also, a number of them now do have cell phones. And so we were working a lot, and they do have reception in several of those areas. And so we were working with a lot of mobile technology for the rural areas in Latin America. Another issue that I think is important to consider when you're working with Latin America, especially rural regions, is that you do work usually with a lot of indigenous communities. And so this means that the language, Spanish might not even be their mother language. And so you have to learn how you can interface with the communities. Also, entering the communities can be difficult, and it does take time as you're a stranger to them. And so, for instance, the work that we did with those rural communities, it was one of my students who worked several years with those rural communities in Guerrero, Mexico. And so, and it took him several years to get involved with the communities and be accepted by them before he could conduct the research. And so it's understanding those types of ways in which you have to work with the communities. And I would say also in the United States, for instance, me as a Latina and a foreigner, it was also hard for me to get into the rural communities in the United States. What I had to do was work with one of my students who was from that region, and he was the one that slowly started to get us into the communities. But it's understanding those dynamics and the infrastructure that you have. And you're absolutely right that it is different.
Really fascinating. Thank you.
Thank you.
I have a question, Dr. Savage. You had mentioned that the AI technology that we use or build for rural communities should or will or likely differ from urban communities. And clearly infrastructure is probably a component of that. I'm just curious if you could give kind of an example of what you mean by that and why there would be two different types of AI versus trying to close maybe the knowledge or experience gap.
Yeah, I think that on one hand, it's important to consider, great question. I think on one hand, it's thinking about that in rural communities, for instance, you might have a majority, for instance, of women who are involved.
Mm-hmm.
As a result, if you have a majority of women, you might want to create technology that is easy for women to manipulate. And so that was why we focused on clay, where it was the women were building large artifacts, which if they were not clay, they would not be able to easily move around and manipulate. And so that's on one hand where it's different, whereas in the city maybe you can easily get people to help you, for instance, to carry things or manipulate them in case you need it. I think it's also considering that For instance, in the cities, you can expect to generally have good connectivity, and you're always connected, working with big data. Within rural regions, it's thinking about that you can have less connectivity. And so how do you work with limited data? Or also maybe it's a region as well that has a large thunderstorms, and maybe it gets flooded and it's not easy to get things back together. And so it's developing technology, for instance, that maybe can work offline for significant portions of the time.
Thank you.
Thank you.
Can I ask David Bao another question? Just, you know, as far as the environment is concerned,
Yes.
right? You know, we use a lot of traditional mathematical models to kind of be predictive about how to intervene, or, you know, what we might see a year or two down the road or whatever, right? So what are the limits of AI in that space? I mean, and where do those limits come from? I mean, just that neural network, like you don't always know what's inside there when you're trying to probe that. And so does that, you know?
Yeah, so I'd say that for these sort of large scale modeling and physics problems, so from what I've seen, there are people pushing on the climate modeling thing, and I actually think that right now traditional models that aren't sort of neural network AI models are still ruling the day, right? You know, traditional models where humans they understand what kinds of things we're approximating in sort of traditional programs. The interesting thing is that in a variety of scientific fields where people have thought that you know, that the physicists or the chemists would understand the best models for another 100 years. A lot of them have been falling very quickly. And so the most dramatic ones that I've seen have to do with chemistry and biochemistry right now. But the AI people are, you know, are continuing to improve modeling in other domains. And so I wouldn't be surprised if in the next few years we'll continue to see advances into other sciences. I think the most famous example of this is the protein folding work that's been done in the last couple of years, and so, you know, it's this famous problem that it's pretty difficult because quantum mechanics is pretty intractable to solve exactly. So physicists have tried to, you know, create models that approximate it, but what AI is good at is when something is not tractable, trying to find good rules of thumb that are pretty good approximations for something that you can't solve exactly. That's how AIs work with our organic data and images and text, and that's how an AI is doing sort of pattern matching to find rules of thumb for how to do protein folding better. And I think that when you have really highly unstable models, like modeling something like climate change, or modeling something like the dynamics of a fusion reactor, that you've got things where the physics have a hard time coming up with stable solutions that you can really model and predict, but an AI can actually it sort of isn't bothered by a lot of special cases and a lot of different things to recognize. Whereas a physicist doing it by hand might say, well, we'll approximate things at 2 different scales. But an AI might say, well, you know, I can learn different rules of thumb for 500 different scales and 1,000 different situations, and it has no problem, you know, deciding to come up with internal tables to divide up the problem into lots of little problems. So, I'd say, you know, we should be aware that there are problems that we currently think are really hard to predict, that probably in the next few years are going to start becoming much easier to predict. And the advance in chemistry, I think, is a good example.
Thank you.
Any final questions? If we don't have any, we can ask the speakers to offer any closing remarks.
So I'll offer just a final closing thought from my side, which is that I think we live in a really unusual time. This tool that has been with us for almost 100 years, computing, has always worked in a certain way with programmers understanding how everything works. But I think that it's important to recognize that we're entering this new era with AI, where we're creating programs of an unprecedented complexity, where a large part of these programs are self-programmed. And I think that it's a time of great opportunity, but I think it's also a time for us to be very aware and to proceed with caution. And so I just wanted to highlight this idea that we're actually at sort of an interesting pivot time for our field and potentially for humanity, encourage people to think deeply and carefully about what we're doing and all the work.
And my closing, I really like what David mentioned about that we are in a pivotal time currently. And I think it's considering that we're at a time where we can create technology that can continue displacing, for instance, the rural workers, forget about them, put them in a very difficult position where it's going to be very hard for them to get into the workforce. Or we can start to design technology that creates new types of job opportunities for this workforce instead of abandoning them. And so we are definitely in a pivotal time to be able to redesign the path that we're going through and reconsider these populations, understanding their values and designing technology for them, especially AI technology that is sustainable and for them. Es war sehr schön, euch kennenzulernen. Vielen Dank und ich weiß nicht, ich hoffe, dass wir können zusammenarbeiten. Danke.
That was spectacular. Thank you all so much for joining us this evening. And please join us again for the next Digital Dialogue.